Looking at graphing the inverse trig functions, um, important to note that if it is a function, that means for each x it has to have exactly one y. And these trig functions can have inverses if you stop the function or the graph of the function so that each x has exactly one y. I'm going to show you the graphs first and then later develop them for the sine, cosine, and tangent inverse functions. Notice that the function stops at negative pi over 2 to positive pi over 2. Also notice that your domain and range are switched. So instead of having your ones on the y-axis, you now have them on the x-axis. And the angles are here. Notice that the inverse function is actually an angle. So real important, the inverses are angles, and that's why your y's are the angles. When you look at this, you're going from negative pi over 2 to positive pi over 2. So when you look at the inverse sine, that means that from 0 to pi over 2, if you're thinking about the unit circle, this is going to be positive, and from 0 to negative 2, your numbers are going to be negative. Furthermore, if you look at the tangent, from 0 to pi over 2, you have positive numbers in the first quadrant. And then when you're looking from 0 to negative 2, you're looking at negative numbers. On here, you have the first quadrant from 0 to pi over 2, your x's are positive. And from pi over 2 to pi, your x's are going to be negative. This is a shortcut in showing where your x's are, positive or negative, in each particular quadrant. So the sine is defined in the first and the fourth quadrant, as well as the inverse tangent, and the inverse cosine is defined in the first and the fourth quadrant. I'd like to develop these graphs based on this particular table. And so if I look at the inverse graph, so you could say y equals sine inverse of x. What you're doing is you're switching the angles and the numbers around. So for example, I'm going to put up the boundaries here. I have 1 and negative 1 going to pi over 2 to negative pi over 2. And as I look at this, I can see that 0, 0 is 1 point. The next point would be pi over 6, 1/2, which means now I want 1/2 pi over 6, which means that's going to be about right here. And continuing on, I would have pi over 2, 1, which means 1 pi over 2. So that looks like this right here in that quadrant. And you can do the same thing for the negative and going from 0 to negatives and see that that is going to look like this. And so this is the inverse sine graph. Let's go to the inverse cosine graph. You could also say arc cosine of x. Again, putting up the general numbers. And notice what happens on this one. 0 to 1 means now 1, 0. So you're starting here. And furthermore, pi over 3, 1/2 means 1/2 pi over 3. It looks like it's right up here. And 0 pi over 2 is here. So the first part of this actually looks like this. Now, on the second part, when you're talking about the cosine, notice that on a unit circle, the cosine is positive here and negative here, if you're thinking about SATC. That's why you have the positive and the negatives covered going from 0 to pi. Sine would be positive and positive. So you couldn't go, you just have positive x's then. So I want to have your negatives covered as well. So therefore, I'm going from here to now, from pi over 2 to pi, which means that if you looked at the unit circle, you would also see that at pi, that's equal to -1. And you could also see this from the cosine graph, that at pi it's equal to -1. So now your x's are going to be negative, and your y's are going to be positive. And so this graph now looks like this. If this were to continue, so if this was just an inverse, not an inverse function, but just an inverse, then it would continue like this and climb up as y's get in, as they increase, and it would climb down as the y's would decrease. Let's take a look at the tangent function. So tangent of x, or tangent of theta, is equal to 0, 1, and undefined. Now, the asymptotes on the original graph went from pi over 2 to negative pi over 2. So I'm going to put those as asymptotes on the y-axis now. So instead of vertical asymptotes, we now have vertical asymptotes. Sorry, instead of vertical asymptotes, we now have horizontal asymptotes. Still, the point 0, 0 is part of this. And if I looked at pi over 4, it's 1. So that means at 1, it's pi over 4. Therefore, from 0 to pi over 2, I now know that this is going to look like this. And if you were to go in the negative direction, in the fourth quadrant, from 0 to pi over to 0 to negative pi over 2, it would get closer and closer to negative pi over 2, yet not intersect it. So how did you get some of these points? You could go to the unit circle to finish out the particular points, but I had to get through this quickly, and therefore I just did the one quadrant and looked at the asymptotes. That's the idea of the inverse trig functions for the sine, cosine, and tangent.